What's up guys, how are you all doing, and welcome to another video. Today we are going to be checking out how to create our very own blind controller that's going to be a little bit different than the last one that we did. This one is going to be for a rotary style blind, where you basically pull a chain and it turns a gear in a rotary fashion. To do that, we're going to be using a motor that was given to us by our good friends at DFRobot. Please check them out down below. A link will be in the description for the part, as well as to their website. But they are the ones that supplied the motor that we're going to be using for this. We're going to 3D print some parts like this case, as well as the gearing and whatnot. We're going to be doing up the electronics and hooking it up to Wi-Fi, as well as hooking it up to the great HomeAssistant hub. If that sounds like something that you'd be interested in, please stay tuned because it's coming up right here, right now on misperry. Okay guys, so I've gone ahead and started on our gear over here. Done some pretty good tweaking to get this to work right. So basically what I did was on this whole thing, I just extruded a cylinder, and then what I did was on the final extrusion, I basically just extruded some cuts of some cylinders, just creating a circular pattern. It looks like it takes about 13 of these cylinders. I measured the chain, and the diameter is about 0.178 is the diameter of each little ball. And for the in-between spots, I had to fool around with it, and I found out that 13 works quite well. 13 little cylinder cuts works pretty darn good. So now what I'm going to do is I'll cancel out of this. And that's basically our gear. I also did, because there's, those little balls are interlinked. So I did a cut using an extrusion. Let's see which one it is. I did basically a work plane and then drew an extrusion on that, and then just made that a cut as well. So that cut that out, as you can see. So, and then of course I measured up the shaft and cut out the kind of like keyed hole for the shaft. And then that should be good to go. So now we need to mess with the box. So my next one that I'm doing is I've got a new part here, fresh sketch, and what we're going to do is we're going to create a rectangle for our box. But first we need to kind of get an idea of what the box is going to look like. Okay, so what we're going to do, I'm going to turn over here to our bench. So we've got these little pieces here, right? So what we're going to do is, I don't know, I'm probably going to bunch these together because it'll probably be, I found that this is just a lithium pack that I had laying around, but it's going to be 2 lithium cells, but they're going to be series instead of paralleled. Now I may have to parallel up more. If I do, I can make the box bigger, so I'll make provisions for that. But it's basically going to be about like this inside that little box. And then I may put the circuit board, I don't know, somewhere in here. So we'll get to fabricating. I need to get my trusty, dusty calipers. Dial calipers, man, I'm telling you, dial calipers is the way to go.
Dial calipers.
They don't need batteries. So what we're going to do is we'll put this together, maybe grab some rough dimensions on it, and we should be good to go. So I'm going to get some dimensions, and we'll start creating the box. Okay, guys, so I've started making the box here, and I've modeled up all the different components. So I've got our gear, I've got the motor modeled, I've got some 18650s modeled up that are going to fit right in there. So, and then basically a cap so we can set the motor in and screw it all down. The holes go all the way through, so that way it will screw into the wood on the side of where the blinds are going to be mounted. So that all mounts up quite nice. We've got a slit here, so that way the chain can come down and wrap around the little motor here, and we should be good to go. Now I forgot to put the lid in here, so I'm gonna go ahead and place that in right fast. So I've got a lid, so I'm gonna throw that down. We're gonna hit some constraints here. We're gonna constrain the top of that with the edge of this, so that should be good to go. And now that's constrained there. So now we got to make sure it's constrained and sits on top. So we're going to constrain that to the side. Good. We're going to do it one more time, and we're going to choose the side constraint and constrain it to the side right like that. And now we're good to go. So there's our case top. I made sure that the top had enough space inside of it. If I make that invisible, there's gonna be enough space in there that I can mount all the circuit boards and relays and other things that we will be needing. So that's gonna be the completed product. Should be good to go. So let's go ahead and get this sliced up in our slicing software and throw it over on the 3D printer and see what she looks like. Okay guys, so now we're on to the assembly part. So we got our parts printed out, excuse me. So here's our box with our spot to hold the motor, along with our basically top clamp that's going to go on there. Looks like it's going to fit our battery just perfectly in there. And then we got our case top that's going to go on. Now, if those of you who don't know, I've made like a lip around it, and then it's also got the same edge. I don't know if you can see that in there, but there's the same edge in there, so that way this will snap. If I can get it to go in. That's the nice thing about these not being exact when they come out after being 3D printed, is that it then makes the friction fit a whole lot better. So, I mean, that's not coming off. So, perfect. So anyway, what we're going to do is we'll probably take our relays. I've already put some wires on one of them. These micro relays is what I'm going to be using. I noticed that not many people have these, so these are available on my Tindie store. I should have a link down in the description, but you can purchase these. What they are is they're basically a 3-volt micro relay that is double pull, double throw, so it's got 2 sets of contacts in it, and it is actuated by 3 volts. And it's also MOSFET protected, so that way you don't have to worry about powering the coil or having any of that inductive spiking.
Spikes are bad.
Or anything going on you know, that could damage your microcontroller. We're going to be using a couple of these because they're teeny tiny. And like I said, you can purchase these from my store. Check that out down in the description. But basically what I'm going to do is I'm just going to use some of our good old servo tape, and I'm going to stick it to the top. I'm going to stick 2 of them to the top, along with our ESP8266 is what we're going to be using. And we'll throw some code on this, and then we'll get this in here as well. Servo tape on the back of the battery, and get that in there as well, and we should be good to go. So let's get started with that. Okay guys, so we've got our board all soldered up now. It came out quite nice. Did some soldering on the bottom. Here is the schematic real quick. I'll flash that up on the screen. All right, so that is basically how we hooked it up. So I'm using 2 of my micro relays. This is a new product available in the Tindie store, so definitely go hit the link down below. Go ahead and install ESP8266. Put that into there. So there we go. There's our board all soldered up, ready to go. There's a battery terminal connector, and then there is the connector for the motor here. So we'll go ahead and we will go ahead and tape that up and get that into the box. All right. Okay guys, so we're going to be taking a look at the code now. So did this all in, of course, Arduino. We're using the ESP8266 Wi-Fi library, as well as the pub sub client, so we can do the MQTT stuff. All you got to do is up here at the top, I've got my direction. I did have 2 different direction variables for different relays, but I chose not to do that, so that's why there's that _1. There's the power relay that turns the power on and off, and then there's the encoder, and so we're putting that on number 3. Now, on an ESP8266, I'll show you a quick graphic of it. Okay, so there's basically, you can use the receive as a GPIO, input and output. You don't have to be limited to just 2 GPIO ports on the ESP8266-01. You can actually have 3 GPIOs if you use transmit only. And we'll see that down here. I just kind of wanted to briefly show that to you. I'm not going to really run through all the code, but I'm going to show you the quick, neat little things that this code is utilizing. The first thing, you've got your encoder limit. So this is how much it will actually, and you know, how far it will go as it goes revolutions. This is basically how many revolutions it's going to make. There's an encoder offset that I have in here. That's for the going up. So, and I've oriented mine where off is down and on is up. Okay, so remember that. Excuse me. So going down, it's about 5,500 counts to get it to the bottom, but then it needs a little bit more, needs about 800 more on at least my blinds. It needs about 800 more counts to get it all the way back to the top, on top of that 5,500. So that's basically an offset. You'll need to tweak those numbers for your installment. And then also, you've got your SSID for your network, your password for your WPA password, and then your MQTT server IP address, okay? And then you'll use your MQTT username, which mine, I left all my stuff default, so if you leave yours default, it'll be HomeAssistant. And then you have your MQTT password. All right, so that's all you have to do so far as setting up this file. And then down through here, like I said, it uses, which is pretty cool. Of course, if it's off, you know, then we run the action to go down. Something I was running into a lot is if you get infinite loops going, it will actually Watchdog Timer out. The ESP8266 will actually has its own internal Watchdog Timer, and if you get into an infinite loop, the whole thing will crash and reboot. So when I do, I'm basically waiting for it to go low, the encoder to go low, because it's an active low encoder, and then once it does, I add one to the counting variable, you know, and of course I'm going to run this loop until I encounter the encoder limit that I set up above. But at the same time, I want to know when, so this will catch the falling edge is what this will do, but then I want to know when the rising edge is, so that way I can reset and be ready to count the next pulse, okay? So that's where this while loop is. Now, I used to just do a while loop and just put a semicolon after it and just let it just basically wait indefinitely until it sees the rising edge. The problem with that, the ESP8266 will bail out. It'll actually kick it out and reboot the whole thing. So you need to delay a little bit of time. You need to do something in that while loop, so it's not just an open-ended infinite loop, okay? So that's what we're doing here. We're delaying just 1 millisecond, and that way it keeps it going. So we're just going to wait till we see that rising edge, and then the whole thing will loop through yet again, and it'll just keep looping until it loops through the 5500 or whatever you have set for your encoder limit. I also programmed in my own Watchdog Timer. Basically, if the encoder count doesn't move at all, which means maybe the motor is stalled or the motor came unplugged or something, it's not just sitting there indefinitely, especially if the motor gets stalled. If it gets hung up or something, you could burn up your motor and tear up your stuff and crater your batteries and stuff like that. So there's kind of a little watchdog counter that I put in here to make sure that that doesn't happen. So if the encoder doesn't move at all when called to move, and you could probably make this better, you could probably save encoder values and say that if at any point the encoder stalls out or something, then quit. But this is just a demonstration video. This isn't an actual product, right? You know, this is just demonstration. So this is all can be tweaked. Download the link down below at GitHub. You can download this code and edit it and do whatever you want with it. But anyway, that was just a quick kind of way of making sure if it stalls out or something that it doesn't just sit there indefinitely. It moves on and allows for more commands, okay? So that's basically what that is. And then we got our reconnect, obviously, if we lose our connection and so on. But here is the cool thing with the serial port. So that way you can still debug, and trust me, this saved me in the debug of this thing, because you can still do serial.println and stuff like that. With this, you do you set up your normal stuff, but you give it the serial 8N1. What that means is that's 8 bits, no parity, and 1 stop bits. Okay, so that's 8 data bits, the N stands for no parity, and 1 stands for 1 stop bit. Okay, and then you put in this one that says serial TX only. That will change the RX, the receive pin, to regular GPIO, so that you can now then use it. And so that's where we set the receive pin, which is our encoder pin number 3, GPIO 3, and we set it to input, and then of course the other 2 are output since we're controlling relays. That's pretty much it to the software. We just put it into a normal loop. I usually give it a delay of 100 milliseconds before it loops back through. And that's basically it, guys, for the software. So let's now take a look at the configuration file in HomeAssistant, so we can make sure and set up that switch to do the right thing and to give the right payload. Okay, guys, so here's my basically my configuration file, my YAML file. So basically we're going to be looking at this section right here, this light portion, because you have to model it as a light. I haven't seen yet. Of course, I haven't updated my HomeAssistant in a while. They may have a new feature for smart blinds and stuff like that you can maybe use for generic stuff. But for right now, we just use light. Now this is also, I have defined up above in this file that I'm going to be using MQTT. I'm just using the local MQTT server. I'm not setting up anything with Mosquito or external or anything special. I'm just using the default MQTT server. If you want to see how that's done, check out some of my other videos on HomeAssistant and MQTT. Just search in my video section for MQTT and you'll see how to set it all up. But basically all you have to do is add a light. You do the platform MQTT, give it a name so that way you can tell it apart in your deal. And then your state and command topics, I make them the same, and I just call it HA and then R blind for Rotary Blind is what I make it. I set the payload on as the word on, the payload off as the word off. You know, so that way we can flip the switch on and off. It will send those payloads, and then of course we interpret it in the Arduino code. Optimistic false. I don't remember what optimistic does right off the bat. I just know that it's in the HomeAssistant documentation. Just look it up. But one that I do want to say is this retain. Now what retain will do is once a device connects to the MQTT server, it will send, the MQTT server, or basically HomeAssistant, will send whatever state HomeAssistant has, it will go ahead and send it to the device. Now, I turned that off. I made it false because what happens is the minute your device connects, if you have your blinds pulled all the way to the top, and let's say that the last command that you did was running them to the top, it'll try to run them to the top again, and well, it'll bind all up and cause problems. So I turned that off, that it won't retain the last known position. It won't do that. Now that's something you may turn on later, but basically what it does is if it was sent and on the last time, or it's currently on, quote, quote, in HomeAssistant, then what it will do is the minute that device connects back up, it'll send the on again immediately instead of just doing nothing till you press the button on the web page. So anyway, but that's all you have to do. You just add that to it and then restart your HomeAssistant, and that should be good to go. So let's see how this thing works. Okay guys, so it looks like we've got all the hardware done, we've got all of the programming done, we've gotten all the circuitry put together. So what we're going to do now is go ahead and run upstairs, and we'll go ahead and install this on one of the blinds up there, and we'll give her a test run. Okay guys, so I've got it all installed up here upstairs. I just used actually some sticky tape because the holes were kind of off, so I'll probably fix that in the model and make it, because I wanted it to match the same holes as this little piece. I haven't cut this little piece off yet. This is the little hanger that goes on the bottom of the chain blinds. I just went ahead and taped it up here because I wanted to make sure it was all going to work before I removed it, because it looks like, I don't know if you can remove this thing without destroying it, so I didn't want to do that yet, so I just kind of taped it up there where it's out of the way. What I ended up doing though for the battery, I think that I'll end up probably putting 2 of those small lithium LiPo batteries in there. I'll probably maybe put, see if I can't find one that's a 2-cell, so that way I can have 6 volts, because the 3 volts just wasn't enough to raise and lower these. So I'll probably do a 6 volt for the motor, and then change that up to a, and then have a separate 3 volt for the controller. The reason that I want to separate that is because otherwise, if I have it the way I have it now, which I've just used 2 18650s, and I spliced off a 1 to get, I put them in series, and then I grabbed 1 for 3 volts, and then around the 2 for the 6 volts, so I can put the different voltages on there. That will cause imbalance problems. I know a lot of you are probably going, you know, so that can cause balancing issues. That's why I would recommend having a 2-cell and a single cell. And you can probably get the little LiPo packs to fit in the space that I have provided here. Otherwise, you can go on Thingiverse and download the model files and whatnot, and modify this as you see fit. But for right now, that's what we're doing, is we're using 2 18650s in series. One, we're grabbing the just 1 cell and pulling the 3 volts off of it, and then we're pulling the 6 volts off the top, just so you guys can see a demo, just because of the fact that I don't have 3 of the LiPo packs. So that's why I gotta order some more, and this video is already taken long enough. So anyway, so we got that hooked up. So first thing we do is I'm going to run, well, the other way. I'm going to pull this down about halfway. The reason I'm going to pull this down halfway, once I get it halfway, the reason I'm going to do that is because, now maybe some of you can help me out down in the comments, let me know, but as of now, I haven't figured out a good way programmatically, and there may not be one. Whenever an Arduino device like an ESP8266 or an Atmel Atmega 328 processor or something like that, whenever those boot up, for some reason, they set all their pins high until they boot up, which causes it to activate the power relay. It causes a lot of different things to happen that is just flat out not good. So this will take off running, it'll get stuck at the top, and it'll end up damaging the motor probably. So
I haven't figured out a way outside of adding more hardware to it. Oh, my dog just came in. Outside of adding more hardware to it to mitigate that factor, because you could put in some NOT gates, basically, or use P-channel FETs instead of the N channel that I've used, and do high side switching where you have to have active low before it will actually switch. So that way when they all go high, nothing happens. It doesn't do anything until you get an active low signal. That's the way to probably do it, but since I didn't have any P-channels, this is the way I chose to do it. So let's go ahead and plug it in. So I'm putting it halfway because it's going to basically run it up when I plug it in, but then once it activates, we'll set up some other stuff and then it should be good to go. So there's a little bit of setup to it. So let's go ahead and plug it in and see what happens. So up it goes. I'm going to back the camera off so we can see fully how it's going to work. Okay guys, so we've got it up here at the top here. So now I've pulled up on my cell phone my MQTT. Hopefully you can see that. I don't know, the light's going to make it probably very hard to see. I don't know if I can shade it. But basically right now I've got it where it's actually at the top and it is switched. I made it where on is open and off is going to be closed, okay? So right now it's on, so it is at the top. So we want to make sure and cinch up all the way to the top. And the great thing about this motor that I'm using with the gearbox on it, you can still manually raise and lower it, even if the motor, and without it having any type of position sensors other than the rotary encoder that counts how many revolutions it goes. It basically doesn't mess anything up. You can move this up and down. It's just you either put it up or down based on what status it is in your HomeAssistant. So now I'm going to go ahead and turn it off, which will make it lower it. And there's the lower. So it should lower it all the way down. Now, I noticed that lowering it causes it to, lowering it goes a lot faster. It doesn't have as much struggle time to go down, so it doesn't take as many counts to go all the way down as it does to go all the way up, okay? So to go all the way up is a little bit different. So you have to put some offset in it. Versus up versus down, because going up you have gravity pulling against you, right? So it's a little bit different on the way up. But as you can see, it closes, and then as we go back up, turn on the up, and it will pull it all the way to the top. Let's give it a second to get into frame here. There we go. There it is working, ladies and gentlemen. So I will go ahead and go back down to the lab and we'll wrap this up. Okay guys, thank you so much for watching. I hope that you enjoyed this video and this tutorial. If you did, throw a like on the video down below. That really helps the channel out, as well as make sure you subscribe and ring that bell icon, because that way you don't miss any of the upcoming content. We got many more videos coming. And also, I want to thank our friends at DFRobot one more time for providing the motor for us to use in this product today. Definitely give them a check out. Down below will be a link in the description to the motor that we use, as well as one more gift that our friends at DFRobot gave me, is they gave me another DFRobot Curie Nano, and we'll be giving this away in future episodes. So like I said, definitely check out, hit the subscribe button, hit that bell icon so that way you don't miss out, because I will be giving one of these away in the upcoming videos. So guys, thank you again for watching. Please stay tuned and we will see you next time.